Session 5, Digital Paleography. Welcome everybody. I'm Lambert Schomaker from the Groningen University, participating in Mladen Popovic ERC project. And we will have 3 presentations. And the first will be by Shira Faigenbaum-Golovin, Algorithmic Handwriting Analysis from Iron Age documents and its implications to the composition of biblical text. Shira Faigenbaum-Golovin is a PhD student at the Department of Applied Mathematics at the School of Mathematical Sciences, Tel Aviv University, under the supervision of Professor David Levin and Professor Joel Skolniczki. Her research strives at designing approximation tools for manifolds embedded in high dimensions. The floor is yours.
Thank you. Thank you for the introduction, and thank you for inviting me here to speak in this conference. And today I will present work that was done by, not by just me, but by my several colleagues, Aryeh Shars and Barak Sover, under the supervision of Eli Turkel and David Levin from the Department of Applied Mathematics, Eli Piasecki from the School of Physics, and Israel Finkelstein from the Department of Archaeology. And I will talk today about the algorithmic handwriting analysis of ancient documents, and more specifically, Ostraca. So this is a long-running project, a short introduction to how it began and where it started, when Israel and Eli decided to do something about those ancient Ostraca. They recruited 3 enthusiastic master students, which later became PhD students. Along the way, we had many collaborations. We had another addition of Eitan Levy joining us in some period, and he will talk today a bit later about his aspect of the project he is doing. And we had recently joined a new student of Or Dalal, which is a student of Nachum Darshowitz, and they are doing some interesting stuff, but I will not talk about it today. And some summary about what we did along the years. So 10 years of work, a lot of stuff have been done. We started with multispectral imaging of Ostraca. For Dead Sea Scrolls, it is known what is the best wavelength range to improve the Ostraca, but what is the wavelength range to improve, to improve the Dead Sea Scrolls? What is the best wavelength range? But what is the best wavelength range to improve Ostraca? So we had an interesting experiment where we eventually came up with the procedure how to image Ostraca the best, and we have even unearthed a new ostracon, which was not known before. This brought to a procedure of how to find Ostraca on the field, a joint project with Eitan. Later, we had some X-ray fluorescence works and Raman spectroscopy also to perform binarizations. As for binarization, we had several works. I will talk about this aspect today in more details. And eventually, using the binarized images, the facsimiles created automatically, we were able to create automatic paleographical tables, which are usually created by hand. And last but not least, the aspect of handwriting separation, which we performed on Arad Corpus and Samaria. And we had an interesting collaboration with the forensic department in Israel about this handwriting separation, but I will not go into details of this either. So today I will talk only about handwriting separation, the algorithm that we proposed for the Arad and its extensions to the Samaria case. So we are talking about Judah and Israel in the First Temple period, prior the destruction of Judah by the Nebuchadnezzar in 586. We're talking about Ostraca because this is the only literate documents that we have from this period, which can give us high levels of statistical robustness in our algorithms. We could use some monumental text, but there were only few of them left. And so we turned out to deal with the Ostraca, which are not that vast corpus themselves. For example, in the Samaria, we have only 119 texts, in Arad 112, and so on and so forth. but this is the information that we have. So we decided to do something with those texts. Because of the amount of text that we have, we couldn't use the deep learning that was just evolving at that time, but we decided to implement and develop tools from pattern recognition and statistical analysis to answer the questions. So the Arad and the Samaria corpus, few words about them and why are they so important for the question of literacy at that period. So the Arad corpus belonged to 600 BCE. This is a corpus which was found in the middle of the desert in the fort called Arad. Basically, this is the largest corpus in Judah. And it's interesting because the paleographers are able to state that this corpus belongs to the last months of this fort, meaning we have a case study which can be studied carefully and examine those inscriptions without any concern. I would say that there's a small remark that almost all of them were belonging to this last month. Later, we have also the Samaria corpus, which was written 200 years earlier in the 8th century in the Israel kingdom, which is Samaria is the capital of this kingdom. And we are talking about the glory times of Samaria, where it was the capital and with all the implications of it. So this is the two corpora that we are talking about. And we wanted to estimate the numbers of writers in those corpora. So the first step was in our procedure was to collect the data, other multispectral imaging or other. Later, we performed character restoration, which means we tried to use binarizations and eventually had a semi-manual method which tracks back the writing style of the person that described. Later, we extracted some well-defined features in computer science and built some kind of measure how to say whether a letter is close to another letter or not. And we had some null hypothesis testing two inscriptions and able to give some probability or likelihood what are the chances that they were written by the same person or not. So this is the general flow, and now I'll go into details of each and every item here. So the data collection was a long term that is actually continuing until now also. We scanned old films and glass negatives of those Ostraca. We traveled along the museums all over the world and in Israel especially. And we collected whatever was possible. Also, we started to use multispectral imaging for those Ostraca and collected high resolution images. Later, in order to compare the inscriptions, we had to compare the letters. We can't really compare the letters themselves as they appear in the inscription. As you can see, for example, in this Ostracon, which is called Arad #1, it's even almost the best Ostracon available to us, and the most visible, so to speak. The letters are not that well preserved. Therefore, we had to create what is called by paleography the facsimiles or the binarizations in order to compare them. However, off-the-shelf binarization didn't provide a good result. As you see here, we have a lot of noise, missing letters, and this was not good for us for the next step of feature extraction. So we developed a new method which manually 2 points on each stroke are marked. And we have some procedure, some optimization procedure, which leverages the proximity to the original stroke while maintaining the interpolation on the stroke and tries to reconstruct the stroke by using this optimization function. In this method, we can reconstruct the letters that we have. For example, here we have two key points that were selected, and the stroke was reconstructed. You see the reconstruction in red, and also here for the Hebrew letter Vav. And we reconstructed the entire corpus of Arad and of Samaria. And later we asked ourselves, okay, we have reconstructed the binary images of those. how can we compare them? So we defined some measurement of comparison, how to compare those letters based on 7 prominent computer science metrics. For example, we compared the shape of the letters, the projection on x-axis or the y-axis, the KD3s, the centers, the shift, and 3 more. And we have now those features that identify each letter. Now we have a set of letters, and we have features that represent them. So instead of just using those features, we created a generalized vector, what we call, which is basically representing how a single letter is different and similar to other letters based on the extracted features. So basically we have for each letter a comparison against all the letters in the alphabet using the features that we have selected. Using this now description, we can actually compare 2 letters and say whether they are same or whether they are different. The intuition behind it was not only that what characterized me as a letter is not only the features that I have, but also my similarity to the other letters in the alphabet and the dissimilarities to the other letters of the alphabet. So now we can ask the null hypothesis whether 2 inscriptions written by the same author or not. And in statistics, it's easier to say something, to negate a null hypothesis than to prove one. So we say something that both of the texts were written by the same author, and we try to negate it. We have some mechanism, and we have selected a priori some p-value threshold, which p-values that are received from this mechanism below this threshold, we say that we reject this null hypothesis. And if the p-values are more than the selected threshold, then we remain agnostic and can't say anything. And this is a good characteristic of the method, that basically we prefer not to say something, not to indicate whether the 2 inscriptions were written by the same author or not, and remain agnostic and be careful from our perspective. So about this null hypothesis testing, about the black box. So we have 2 inscriptions, and we have alepphs in 1 and alepphs in 2, and we compare the alepphs between themselves. We throw them in one pile, and based on the general description that we defined before, we can let the computer cluster those 2 letters into 2 different sets, and say that one set is similar to between one of them, and the other one is similar to between them inside. Now we can ask what is the adherence to original inscriptions, meaning what are the chances that the original inscriptions were perfectly separated using those clusters. If we indeed have one writer, then those letters will be mixed up and we will not have a perfect separation. But if we have 2 separate writers, the adherence to the to those clusters will be perfect. And we can measure the amount of perfectness of this clustering. And this eventually, this method gives us a p-value, a probability that those 2 inscriptions were written by the same author or not. So we can have a p-value for the alepphs, we can have p-values for the hays, and for other letters. So we had reconstructed for the Arad case 7 letters, and for each one of them we calculated the p-values, and eventually using the Fisher method we combine them to a single p-value. So for 2 inscriptions we have a probability that they were written by same person or not. We tested this methodology on modern writing, Hebrew writing, which we collected manually, and this resulted in an error of 2.6 false negatives and 4.7 false positive, and we were quite happy about those results. So we decided to apply it for the Arad case. The Arad case, as I said, it's a fort in the middle of nowhere where a quite big corpus was found. We took the 18 inscriptions which were had enough letter statistics in order to compare them. And we reconstructed the letters and later selected threshold of 0.1 for the null hypothesis testing. And basically, say something about the inscriptions. It's inscriptions that were sent to the Arad, to the quartermaster, most of them, of the Arad, which is named Eliashib. He was sitting there and giving provision for everyone that came there. And we wanted to know how many writers were in this corpus. So we compared inscription number 1 versus inscription number 2 and versus inscription number 3 and so on and so forth. And eventually we got such a table with pairwise comparison of all the inscriptions that we have. I marked in red the inscription separations that are less than the selected p-value of 0.1, and we see that there are quite a lot of separations, but what does it mean? So now we can find pairwise separated pairs, and eventually we can, after analyzing how many cliques of writers do we have here, we see that we have 5 different writers algorithmically. And the chances for finding this amount of writers by chance is very, very low. It's 10 to the -6. So we were quite happy with the results. 5 writers in a corpus of 18 inscriptions that were quite impressive. We were able to reconstruct and give something, some interesting result about the Judah army apparatus, that the assistant to the king, the commander of the Arad fort that was sitting outside the Arad, the Eliashib, the quartermaster, and even the subordinate of the quartermaster, which is a poor man sitting there, knew how to read and write. And those were the interesting results, historical results of this. And this was published in 2016 in the PNAS and hit the New York Times front page. And we decided, okay, we have a methodology, let's apply it for the Samaria case. With Samaria, we have also a set of inscriptions, quite a lot of them, we can compare them and let's play with it. However, the inscriptions are quite short, so we were kind of cautious about the results. So we performed all the flow that I talked about before. We constructed the letters, we compared the inscriptions, and we received this table of separations. And in this table, as you can see, there are not quite as much as separations as we had in the Arad case. In the Samaria, just to say a few words about the 2 corpora, we had 31 inscriptions, while in the Arad we had 18 inscriptions. While in the Arad we had 44 separations, the red marks in the table. In the Samaria, we had only 10 separations. And based on those 10 separations, we can say that the minimal number of writers is 2 in this corpus, but what is the maximum? So that question was still unclear to us. So we decided to develop additional mechanism in order to answer this question and find a maximum likelihood estimate of how many writers were in the Arad corpus that we tested. So our main concern was that the algorithm is sensitive to the length of the inscriptions, meaning the Samaria were much, much smaller than the Arad. So we decided to estimate the errors that we have in the algorithm of misclassifying short inscriptions. And we decided to measure the false positive and true negative, true positive and false negative. And basically based on those errors of the algorithm to estimate the number of writers in the Samaria case. So in order to do this, we took the Arad corpus, which was closer to the Samaria as possible as the one that were available to us, with all the reconstructed letters, and we simulated 2 types of inscriptions, short inscriptions. First of all, we took some statistic about what is the length of inscriptions existing in Samaria, and we simulated those inscriptions with 2 free letters, 4 verse 2 letters. We took an inscription which was assumed to be written by a single author by all scholars. We divided it to 2. Now we have 2 inscriptions, and we can evaluate the error of mixed classification of our algorithm for a single writer. The same we did with multiple writers, while assuming that the Arad separations were true. So we took two inscriptions that were separated in the previous step by the algorithm of the Arad case. We sampled from them the configuration of the Samaria, and we got the error of misclassifying for the separation part. So now, having those errors, we are able to build the probability distribution function for assuming each number of writers. So for example, first we assume that we have one writer, and then we calculate the probability distance function. Next, we assumed we had two different writers and three different writers, and for each such test case, we received a probability distribution. Now, given the 10 separations that we have in Samaria, what are the most likely number of writers that we have? In this case, the most likely number of writers, the higher curve here, is number 2. So again, we received that the most likely number of writers in Samaria is 2, not only the minimal number, but also the most likely one. So, okay, so we have 2 writers in a corpus of 31 inscriptions. So who were those writers? What can we say about them? I didn't tell you this, but the Samaria corpus contains many information. Each inscription is actually documents a commodity that was brought from a specific town by a specific person, the commodity type, the year that it was brought to the Samaria, 10, 15, or 9. And basically we have a lot of information. So can we identify those clusters which belong to either of those characteristics of the inscriptions? Can we say that, that the first writer was writing in the years of 9 and 10, and the second one was writing in the year of 15 to specific king? So apparently we were not able to cluster by any characteristic of written on the Ostraca those texts. So we concluded that probably those writers were contemporaneous, and they were probably seated in Arad, in the gate, so in Samaria, in the gate of Samaria, and writing and documenting the commodities that were brought to the capital city. And this has something to do with the central administration, which was probably existing in Samaria.
Can you round up, Shira?
Sorry?
Can you round up?
Yeah, this is the last slide. So now we can actually compare the situation in Samaria to the Arad, where in Samaria we had only 2 writers sitting in the capital of the city. And in the Arad case, we have multiple of writers which are located all over the area located around the Arad. And basically this has something to do with the composition of biblical text, where suddenly with the flourishing time of the Arad, we have many literature. Maybe there was a possibility of composing biblical text, because there is always a question whether the texts were composed maybe earlier, maybe in the exile. So we can say that probably in the 7th century, maybe texts like Josiah or 2 Kings were written somewhere in Judah. So if you want to know more about us, we have a site. So just click Nuclear Ostraca and you will find us. And so thank you for your attention.
Thank you, Shira. Other questions? You can put them in the chat or announce them. I've very say a technical question. You choose for the 2 writer setting, but the peak for the let's say the Monte Carlo count for 1 writer is much higher. So what makes you decide for the 2 writer solution?
The 2 writer solution was based on the observation that we have 10 separations. What is the number of writers that could have resulted in 10 separations that we have in the table of the Samaria.
Okay, okay. So yeah, so the frequency of the single writer solution is all coincides, of course, with less separations, right? But
yeah,
so there is a kind of possible bias maybe going on. But yeah, it is true that the Gaussian for the two writers also is somewhere in the middle. So that also gives an indication of its special status.
Yeah.
Other questions? Yeah, so okay, this study, Jonathan Bendov says to all panelists, answering my question from an earlier session, this study is not conservative in terms of statistics. But what would be your comment on this, Shira?
What do you mean not conservative? I believe that
maybe the 0.1 alpha that you used.
The alpha, but selecting a p-value threshold is something that is trackable. Once we select a threshold, we know what to expect. We know that we can receive the 10% of errors. We can even track it down and actually see. The algorithm is very transparent from this point. We can see where the p-values for each letter and what letters actually brought to this low p-value or high p-value. And actually that's how we debugged it. So there's no black box, as it say, as we think about the AI usually.
Yeah, no, that's clear. And the lack of data maybe pointed you to the 0.1 threshold. Ira Rabin has a question. Did you publishing anything on the Raman imaging?
Yes, we have a paper on the Raman imaging. It's a proof of concept. Basically, we had a scanner which was constructed in collaboration with the chemistry department for their purposes, and that's why it was not optimal for the Ostraca case. And we were able to scan several letters, the main, and succeeded in identifying the Raman peaks, and were able to produce a good binarization. But the main problem why I call it a proof of concept, because it took a lot of time to scan each letter. So if someone is after doing Raman scanning of Ostraca, it's possible, but needs better equipment.
Okay, thank you. There is also a remark by William Schniedewind stating that this study illustrates how interpretations can be problematic. It compares apples and oranges. The Arad corpus likely includes letters sent to Arad, whereas Samaria illustrates maybe two scribes working in a government office.
I see the point why it may be problematic. Yes, the Arad corpus contains letters that were sent to the Arad case, but not only. We have three Ostraca that are actually listing are a list of names. It's like a list of people that were sitting in the Arad at a specific time, like the names of the troops. And I didn't mention it also, but they were in different group because there were only 3 writers that were separated and not the 5 that were the interesting ones. So we have a separation between 3 of them, which are believed by the scholars that were composed in the Arad itself. So already we have 3 writers in the Arad as opposed to the 2 in the Samaria. And yes, we have plenty more. And even
maybe William can answer this by unmuting.
Yeah, I mean, this illustrates a problem of different also groups of scribes. So Arad is a military outpost as opposed to a government office, and you could actually do a control and look at one inscription from Pithos B of Computerized root and find at least 3 different hands on one inscription. This is from 800 BC. So this would illustrate a military outpost where you have multiple scribes in one place. 800 BC, it wouldn't really necessarily tell you anything about literacy in society. It would tell you about the use of writing and literacy in one sector of society, in this case, military, which probably isn't located to 600 BC. It's probably something that's generally true of military at lots of different times. So I have problems with the interpretation of the data. The science behind it is interesting, but the interpretation is going to be up for a lot of discussion, I think.
Okay.
I should mention something about the Arad case. The Arad is thought to be that writing are kind of a school of writing. So there were many students learning how to write the alphabet, and of course there are many people that wrote because they were studying there. So I think it's a different test case that what we are having here, a royal documentary of commodities. As I agree that the situation is different, but that's basically.
Yeah. So sorry. In view of time, I think we have to stop the questions session. So thank you very much, Shira, for this very interesting and provocative results.